Welcome to the DIY Honda Garage channel. The DTC P16E5 indicates a LIN communication error between the Powertrain Control Module, PCM, and the DC-DC converter in the Honda CR-V 2023 and later models. The LIN, or Local Interconnect Network, is a communication protocol used in various vehicle components to exchange data. When the PCM detects that it cannot receive signals from the DC-DC converter through the LIN, it triggers this DTC. This error may affect vehicle performance as the PCM relies on this communication for proper operation of the powertrain system. The PCM is typically located in the engine compartment, while the DC-DC converter is often near the inverter, connected to the power supply of the vehicle. It's essential to troubleshoot this error promptly to prevent potential vehicle operational issues. The DTC P16E5 signals an issue with LIN communication between the Powertrain Control Module, PCM, and the DC-DC converter. The PCM is the vehicle's central control unit, responsible for managing engine functions and ensuring efficient power distribution. The DC-DC converter is crucial as it converts high voltage from the battery to lower voltage used by various vehicle systems. If the PCM fails to receive signals from the DC-DC converter, it indicates an abnormal scenario that must be addressed to maintain optimal vehicle performance. The LIN protocol is a simple, inexpensive communication bus used to connect various vehicle components, allowing the PCM to receive vital data. Both the PCM and the DC-DC converter are generally housed in the engine compartment. There are multiple potential causes for the DTC P16E5. A faulty Powertrain Control Module, PCM, may fail to communicate effectively with the DC-DC converter. Additionally, problems with the DC-DC converter itself could lead to communication failures. Open circuits in the wiring connecting these components can disrupt communication, potentially leading to this error code. Likewise, a shorted LIN circuit can cause incorrect voltage levels, resulting in a communication breakdown. It's essential to inspect each of these components systematically to pinpoint the specific cause of the error. The symptoms associated with DTC P16E5 can range from minor to major operational issues. One common symptom is the illumination of a warning light on the dashboard, alerting the driver to a potential issue within the powertrain system. Additionally, the vehicle may experience reduced engine performance, making it sluggish or less responsive during acceleration. In some cases, the vehicle may fail to start entirely, indicating a severe communication error between critical components. Diagnostic tools will likely present multiple error codes, further guiding the technician in narrowing down the source of the problem. The first step in troubleshooting DTC P16E5 involves turning the vehicle to the on mode without starting the engine and waiting for 10 seconds. This step allows the Powertrain Control Module, PCM, to perform an internal check and establish connections with other components, including the DC-DC converter. Following this initial wait, the technician should check for the presence of DTC P16E2. If DTC P16E2 is indicated, it suggests further complications within the system and may require addressing that code before DTC P16E5 can be resolved adequately. In the second troubleshooting step for DTC P16E5, the technician should inspect the IG1 ACG circuit and assess the LIN BAT sensor to determine if there are any faults. The inspection should include verifying the integrity of the wiring and connections. If there are no visible issues, the technician should proceed to check for any shorted wires that may be affecting communication between the components. This step is crucial, as any abnormalities in these circuits can significantly hinder the functioning of the LIN communication system, leading to the generation of this error code. In this step, the technician is required to thoroughly inspect the DC-DC converter. First, all connections and terminals should be examined for any obvious signs of wear, corrosion, or loose connections that could impair functionality. It is also essential to ensure that the converter provides the correct voltage output as dictated by the specifications. If the DC-DC converter shows abnormalities or fails to meet voltage requirements, it may need to be replaced or repaired. This step is vital since the DC-DC converter is directly involved in managing the power supply and communication signals within the vehicle systems. The fourth step in the troubleshooting process for DTC P16E5 involves a detailed inspection of the Powertrain Control Module, PCM. The technician should check all connections and wiring associated with the PCM to ensure there are no issues such as corrosion or loose connectors. Following this, the performance of the PCM should be evaluated using appropriate diagnostic tools to ensure it operates within standard parameters. If the PCM is determined to be functioning improperly or shows signs of failure, it may require replacement. This step is critical, as a faulty PCM can lead to various vehicle performance issues and continued communication failures. After conducting the necessary repairs for DTC P16E5, the final verification step is crucial to confirm that the repairs were effective. The technician should clear all DTC codes from the system and perform a test drive to allow the vehicle's systems to re-establish communication and monitor overall performance. During the test drive, it is essential to pay attention to how the vehicle operates, looking for any signs of previous symptoms or warning lights. Finally, it is advisable to monitor the vehicle for any reoccurrence of the error code over the next few days. An effective verification process ensures that the root cause of DTC P16E5 has been addressed and the vehicle operates correctly. To prevent future occurrences of DTC P16E5, implementing preventive maintenance practices is essential. Regular diagnostics checks can help in early identification of potential issues with the powertrain components. Technicians should be instructed to routinely inspect wiring connections for signs of wear or deterioration, as these can lead to communication errors over time. Additionally, maintaining clean terminals and connections is vital for ensuring proper electrical flow and signal integrity. By adopting these preventive measures, the likelihood of encountering LIN communication errors can be reduced significantly, enhancing the overall reliability of the vehicle. In summary, DTC P16E5 represents a LIN communication error between the Powertrain Control Module, PCM, and the DC-DC converter in the Honda CR-V 2023 and later models. Addressing this error requires thorough inspections of the PCM, DC-DC converter, and the related wiring and connections. Each potential cause must be examined carefully to ensure all possible issues are identified and resolved. Following a systematic troubleshooting process will help mitigate the symptoms and restore proper vehicle functionality. Additionally, adopting preventive maintenance measures will contribute significantly to the vehicle's long-term reliability. Please like and subscribe to the channel. See you next time.